Hello, everyone. Welcome to week 2. A couple of announcements. Make sure that you are thinking about your projects and what kind of videos you would like to make, and make sure that you reach out to me at some point this week so that we can chat about your project. Other than that, I hope you've had a good weekend. Hope you had a chance to relax a little bit, do some reading, enjoy the day. It's been beautiful out today. Today, and probably for the next couple of days, we're going to be spending some time talking about climate change in cities. And I won't spend a lot of time on each particular aspect of climate change because we will continue to revisit those things throughout the quarter. But I'm putting climate change sort of front and center in the course because honestly, everything that's happening right now in ecology in cities is being affected by climate change, right? So it's important that we understand the basics of climate change and how that's affecting sort of the most generic things that are happening in our urban ecology before we dive into those a little bit deeper. So today will just sort of be an overview of climate change, and then Wednesday we will talk quite a bit about the urban heat island, okay? All right. So what is it exactly that we're talking about when we talk about climate change? Now, several of you have had this in class, whether it's been with me or with Binny or someone else in the bio department here, and hopefully maybe you've even had some of this in physics and chemistry and some of your other classes. But for the most part, we think about climate change as being sort of this whole kind of gloom and doom negativity. And we often think, right, about, and you should be thinking about raising global temperatures, right? Because that really is one of the key issues with climate change. And the other one, of course, is the increasing greenhouse gases. And we tend to focus on carbon dioxide, and because that is one of the most, I think one of the ones that has increased the most over the past 100 years or so. And we have a lot of really good data about increasing CO2, but we also need to talk about some of the other greenhouse gases like methane. And methane is also very important and has much higher heat holding capacity even than carbon dioxide. So we think about things like drought, we think about extinctions, we think about, hopefully you're thinking about fires right now. We'll spend some time on fire today. Also droughts, right? Changing weather patterns, increased storm surges, increased storm intensity. A lot of things happening with the weather out there. We also think about the Arctic, right? There has to be a polar bear picture when we talk about climate change. So here is our polar bear. And when we're talking about the Arctic, we're talking about typically global ice cover, right? So how much ice is in the Arctic, how much water is being stored as ice, how much carbon is being stored in permafrost in the tundra. And all of these things go into this big, massive sort of data information set that we have about what is climate change and what is happening out there. So really the two main factors that of course I want you to know, and if you've had me in class before, you know that this is where we start, right? We talk about increasing global temperatures, average global temperatures, and increasing greenhouse gas concentrations. So those are the two main things that I really want you to understand are the major issues associated with climate change, and pretty much everything else that we have negatively associated with climate change, drought, extinctions, changing weather patterns, all of those things come back to these two main factors, okay? So we know that average global temperatures are increasing. We also know that here in Michigan, we are getting strange weather patterns in the winter that bring us unbelievably cold weather from the Arctic, right? We call those polar vortexes. And we've had several of those in the past few years. And of course, one of the common jokes that I see on Facebook that I hear in Meijer when I'm shopping or doing whatever is, oh, it's so cold today, global warming, haha, that's not really a thing. Obviously, it's minus 42 degrees outside. Well, the reason that we're getting those strange weather patterns is because the Arctic air is warming so much that it's pushing that cold air down. right? So when we talk about temperatures, increasing temperatures, we're talking about averages over time, okay? And we're talking about globally, not just here in Little Kalamazoo, Michigan. And so we're talking about average global temperatures. And when we're talking about greenhouse gases, like I said, we're talking about almost all the time we focus on carbon dioxide, but we're also talking about methane. We're also talking about nitrous oxides and sulfur oxides. Okay, so multiple greenhouse gases out there are increasing. It's not just carbon. And so the main factor in all this, of course, is the use of fossil fuels. And if you think about what fossil fuels are, the concept of climate change is actually very straightforward, and the chemistry is very, very simple. Okay? So fossil fuels really are remnants of organisms that have been kind of compressed into goo in an oxygen-free environment. Okay? And if you think back to your basic kind of biology about what happens when you take oxygen out of an environment, it means that things can't decay. Right? And so what happened is all of this plant matter, animal matter got compressed underneath a bunch of sediments in an oxygen-free environment, and it sort of just turned into black goo, right? And you can think about some of the raw fuels that we have, raw fossil fuels. You know, it's just sort of sludgy, rocky stuff down there, and it's been compressed, and it has sat there, stored under the Earth's, you know, surface for millions of years. Okay, so all of that carbon has just been sitting there. They're fossils, right? That's how fossil fuels got their name. They are fossils. They were once critters. Now they are just sitting there unable to decay. Okay? It is a non-renewable resource. We no longer have enough creatures or enough plant matter to form fossil fuels, plus who has that much time, right? You nor I have a million years just, you know, hanging out here. And the one thing that I think people get hung up on is the fact that, yes, burning fossil fuels is a completion of the carbon cycle, right? Bringing that carbon up, it is natural, right? But burning that carbon at the rate that we have been burning it, after it has been stored for millions and millions of years, you know, that in a 100-year period, that's pretty quick. You're adding something to the atmosphere that has been stored, that has been tucked away and left to just sit there. Suddenly humans are like, oh, I can use this, let's bring it out, let's burn it up, it gives me fuel. And suddenly all of that carbon is being released into the atmosphere. So it actually does make a lot of sense. It is actually exceedingly straightforward. And the issue with climate change is a political one in the United States, right? It is not a matter of whether it is happening or not. It is a matter of who is paying the politicians to look the other way. Okay, so it's very important that you kind of familiarize yourself with what climate change is, and that you understand that the chemistry really does make a lot of sense. So when we talk about cities and climate change, we have to think about the effects that cities have on climate change, right? How are they contributing to climate change? And worldwide, cities produce about 70% of the greenhouse gas emissions that we have. And so this is, of course, New York City. And this is the Empire State Building, sort of covered up with all of the carbon. If you put all that carbon into little beads and piled it into one place, this is what it would look like in one day in New York City. So lots of carbon is being produced in emissions and letting go into the atmosphere. And what is driving that? Right? So part of it is vehicular traffic, right? Cars, trucks, buses, whatever it is that's driving around downtown New York City. It's also heating and cooling, right? Both in the summertime and in wintertime, you are using fuel to regulate the temperature. Okay, it's running municipalities, it's flushing the toilet, it's cleaning the water, it's you know, all sorts of things that go into cooking and cleaning and just humans doing their everyday thing. In addition to that is consumption, right? What are we buying? What are we using? What are we throwing away? Okay. So 70% of the world's greenhouse gas emissions come from cities. They also consume about 2/3 of our global energy. Okay, and again, that's in the form of heating and cooling and transportation and getting goods and services from one place to another, okay, which I guess is also transportation, but and then the consumption of those goods, the packaging of those goods, the shipping, all of that stuff, right? So cities consume a lot of our global energy, and by 2030, just 10 years down the road, they will house about 60% of our human population. Okay, so cities affect climate change a great deal. Lots of contributing factors coming out of our major cities and our minor cities worldwide. One of the things, like I said, that we will talk about on Wednesday, and we will spend the whole day actually on the urban heat island. One of the things that is particularly important when we talk about cities and climate change is the establishment of the urban heat island, and also how the urban heat island affects other things that are happening in the ecology. So just a very brief sort of introduction as to what the urban heat island is. It's basically saying that all of that built environment out there, sidewalks, roads, buildings, you name the buildings, schools, hospitals, houses, marketplaces, all of those hardscapes, all of that built environment throughout the day is absorbing heat, right? As it's absorbing heat, it stores it, right? Think about picking up a brick or putting your hands on hot pavement, right? Pavement gets so hot, even here in Kalamazoo in the summer, that you can't walk on it barefoot, right? So it's absorbing all that heat, it's storing all that heat. That makes the urban atmosphere typically sometimes between 5 and 10 degrees hotter than it does in the surrounding suburban areas. Okay, so this is just simply, this is a very simple graph, and these are late afternoon temperatures. So after the sun has warmed the sidewalk and stored some heat through time, this is around 3 or 4 in the afternoon. And you can see very clearly how those temperatures are fluctuating when you are in a downtown area versus when you are in a rural area. So in addition to the fact that we have a lot more hardscapes and a lot more built environment downtown, you should also notice that there is one sort of key organism lacking here in downtown, and that is trees, right? Trees and vegetation help keep rural areas cool. And they do that in 2 different ways. They do it by shading, for one, and the second way that they do that is via transpiration. Okay, so moving of water from roots to shoots and out through the stomata. The plants are basically sweating water out into the atmosphere. And when you are in an area with a lot of plants, the temperature of that atmosphere is much cooler. Okay, so part of it's shade, but part of it is also transpiration. And that's why when you go into a park that has a lot of vegetation in it, it feels cooler. Think about sitting under a tree on the quad. That shade is also cooling you down, right? So the urban heat island is a very, very important part of urban ecology, not just from a human point of view, but also from a plant and animal and fungi point of view. Okay, so that's just sort of an intro to the urban heat island. And this is what that looks like, right? If you take a heat map of, this is New York City, looking at it from the ocean, okay? And you can see how much heat these buildings are absorbing. So any of the pink areas or orange or red, these are hot, right? Hotter than the blue areas or the green areas. And you can see, of course, the water is nice and cool. And as you kind of look across the landscape there, you can see it cooling down a little bit. But certainly those buildings that are facing the sun are absorbing a lot of heat, right? So that's sort of what it looks like. So the urban heat island causes all sorts of positive feedback loops. And if you think back to ecology, when we talked about what a positive feedback loop is, hopefully you remember that it's simply when the product of one reaction leads to an increase in that reaction. Okay, so here's a good example of a positive feedback loop within a city. All right, so it's hot, right? Climate change is happening, it's warmer outside. It's hot out there today. So you come home, you've had a rough day, you come home, you sit in your chair, you turn the fan on and you turn the air conditioner up, right? You're gonna cool off. That leads to increases in the amount of electricity that's being used. When you increase the amount of electricity, you are increasing the amount of fossil fuels that you're using, which in turn increases global temperatures, which increases the amount you're turning the air conditioner on, which increases the amount of fossil fuels you're using, which again, right? So you can see how an increase in the reaction goes through a couple of steps, but leads back to this loop, leads back to an increase in that same reaction. Okay, so that is a positive feedback loop. This happens a lot in multiple different ways in the urban heat island. And so global environmental change, and when I'm talking about that, I'm talking about climate change, I'm talking about increases in heat, I'm talking about all of the effects, right? So drought, crazy storms, all of these things are changing, right? They are changing, and those changes are further exacerbated by land fragmentation. So we talked briefly last week about how the increase in the number of populations around cities, of course, changes the outlying natural areas into urban sprawl, right? And as you are sprawling cities sort of across the landscape, you are fragmenting that landscape. You're removing trees and vegetation. You are changing soil properties. You are adding buildings, sidewalks, roads. As you are changing that landscape, you are changing our climate. You're changing how storms approach a city or how intense they might be in a city. You're changing fire regimes. You're changing all different types of things that are occurring, right? So invasive species go up when we have a fragmentation. We have an increase in pollution, light pollution, water pollution, soil pollution, noise pollution is important. And of course, while you're kind of skimming all of the trees and plants off of the surface of the earth there, you're also adding to deforestation, which changes trees from carbon sinks into carbon sources. And so all of these things that are happening while we're changing the land use, those things are all adding to climate change. Okay. So just an example here of how invasive species do that, because that's one question that I get often. They're like, well, I understand the concept of invasive species, but how is that adding to climate change? And it's actually a very simple example, one that we have here in the state of Michigan, right? So this is emerald ash borer. This is the insect that I worked on for my PhD. And it was brought to the United States in solid wood packing material. Okay, and what does that mean? That means it came here in a crate, okay, some kind of wooden crate or pallet that goods were packed on, right? And if you look at this particular boat, this is a very typical boat full of goods from overseas that Americans like to buy. And each one of these little colored blocks here, that's a train car. So you can kind of get an idea of how much stuff is sitting here in this shipyard getting ready to go out on these boats. So it's pretty incredible the amount of goods and services that we import into this country. So anyway, this little insect, right, hitched a ride. It was like, well, I'm living here in this crate and off I go across the ocean, and it managed to establish itself here in the state of Michigan. And in doing so, when it arrived, it had an abundance of host material. So meaning that there was plenty for it to eat, and it didn't have any natural enemies, right? So typically those things evolve over millions of years, right? These sort of relationships that organisms have with their prey or as prey. So the creature got here, little ash borer got here. There was nothing that ate it, nothing that recognized it as food, but it was able to eat ash trees here in the United States as easily as it was able to eat ash trees in its native environment, okay? So it came in, this is a picture that was taken before ash borer arrived, nice and green, lots of shade, lots of great ecosystem services happening from these trees, right? Some transpiration and some reduced cooling, lots of good stuff, okay? Ash borer came in, killed all these trees in a matter of about 2 or 3 years. Across the state of Michigan, we lost literally tens of millions of trees in our cities and also in the rural outlying areas. Okay, so this is how invasive species can exacerbate global climate change. Okay? Think about all these trees. They used to store all this carbon. Now these trees are dead. Now all that carbon is being released into the atmosphere. In addition to that, think about the cooling effect that these trees had. That has disappeared now too, right? So a lot of things occur when we introduce an organism that was not evolved to be here, okay? And we introduce that into our natural ecosystems and we start changing things very rapidly, right? So this all occurred again within 3 or 4 years of this insect's arrival. We're also seeing a lot of water pollution in the form of algae blooms across the global cities. This is Portland, Oregon. And if you remember back to last week when I was talking to you about how water warms up as it moves across the surface of roads, as it moves across the surface of sidewalks, increases in temperature typically cause reactions and plants, of course, to grow much quicker. And so you get these blooms of algae near cities because the water is so much warmer in those spaces than it is in the open ocean, or even, and we see this actually quite a bit in Lake Erie as part of the Great Lakes. So these things aren't just happening to coastal cities on the oceans, they're also happening to the coastal cities that we have at the 5 Great Lakes. Air pollution is pretty straightforward. The one thing that I want to say about air pollution is, again, we tend to focus and we tend to shame cities across the country or across the globe, right? We think of Delhi in India as being a very, very intensely polluted area, especially with regard to air pollution. But we should not be throwing those kinds of stones, right? Even in cities that I think of as being very clean, like this is Calgary in Alberta, Canada, the air quality in these cities is being reduced dramatically because of global climate change, right? And again, this is, there's a lot of things happening here. That's increases in temperature, allow the air to hold more things. But in addition to that, we have things like fires that are raging across the country and causing particulate matter to go up into the atmosphere. So air pollution is a real problem, and it is also contributing to climate change. Again, another positive feedback loop. Right? You have air that looks like this, you need to filter it. What filters it? Something, some kind of fan, some kind of filter run by fossil fuels. What happens then? Those fossil fuels go and increase the global temperatures, which increases fires, which increases how much air needs to be filtered. And so again, you can see how these cycles are occurring in urban areas. So lots of effects of climate change on cities. And if you just sit and think about a couple of these for a minute, you'll come up with a whole list of them. Right? And so you come up with all sorts of things. And these are the ones that we think about most often. Storms, increasing storm intensity, increasing in storm duration, right? How long storms last, how frequently they arrive, increasing temperatures, decreases in temperatures like our polar vortexes, right? Changes in infrastructure. How are we going to build new structures that can be more efficient, that can handle hotter temperatures? You know, think about living in your dorm when it was super hot. You know, how can we ask students to continue to do that as climate change is occurring and temperatures are increasing? So many issues on human health, right? So many. And we'll talk about some of these when we talk about the urban heat island. Heat stroke alone and heat-related deaths and injuries have absolutely spiked all across the world. Changes in sea level, right? Sea levels are rising. And you might not think that 1 or 2 inches in sea level is that big of a deal, right? but think about how waves are crashing into the shoreline, right? What is there to protect the built environment that is 2 or 3 inches in when you're talking about waves crashing, against those particular buildings and against the levees and against the bridges. So sea level is extremely important when we're talking about storm surge. And storm surge is just a factor of atmospheric pressure. During certain weather events, the pressure makes the ocean swell. And as it swells, of course, it rises up, right? And in some areas, like during Maria, during the Puerto Rico hurricane, you're talking storm surges that are multi-stories high, right? So imagine what would happen if Lake Michigan suddenly, right, raised itself up 12 or 15 feet. Where would that put us as humans along not just the shoreline, but even further in, right? Because that's a lot of water. Ecosystem health, of course, is exceptionally important as well. It's not all about humans. It's about keeping the trees healthy. It's about keeping the fungi and the decomposers and those types of things happy. It's about water, right? Water quality, air quality, algae blooms, all of those things, right? Here's one I think we don't think about very often, and that is tourism. Okay? Who wants to go to a city that has bad air quality, that has algae blooms that smell like sulfur, that has intense heat or intense cold, right? Tourism around the globe is changing dramatically because of climate change. Food security is another one, and we'll talk about food security quite a bit towards the end of the quarter. How do we ensure that people who live in cities and who live in the sprawled areas on the outside of cities, how do we ensure that they're getting healthy food and enough of it? So that's very important. Climate displacement is another one. We'll talk about that here in just a second. And another one that you might not think of very often are disease vectors. Now, a vector for a disease is an organism that carries the disease. Okay, so the best example of this is, of course, the malaria and the mosquito that carries it. Okay, so mosquitoes breed in quiet water, and they can breed in something as tiny as a little glass, right? If I were to put this outside and let water sort of collect in it, within days, I would have a breeding mosquito population. As we are getting more and more rain events, more intense rain events, warmer rain events, in many, many areas, little pockets of water are sitting around and breeding mosquitoes. And so we're getting more mosquitoes in urban areas, which carry the malaria disease around, right? And malaria is just one example. If you think about ticks, here in the state of Michigan and ticks vector Lyme disease. Lyme disease is also increasing across the globe. So disease vectors are another one that we don't think of very often, but they're very important on cities and human health. Okay? So there's just sort of a list of 10 things that are happening in cities that are the result of climate change. About 70% of cities are currently, right now, got really excited and I pushed the button. 70% of cities are currently dealing with the effects of climate change. Right now, as we are saying this, as we are working through this slideshow, 70% is happening. I get really frustrated when I hear people say, well, it's not happening here. Yes, it is. You just are not aware of it. You're not seeing it. And perhaps your privilege has allowed you to continue your life without feeling the ramifications of these things. Right? But we are dealing with the effects of climate change as we speak, even here in Kalamazoo. Okay? Another really important statistic is that 90% of our cities are on coastlines. Okay, when you have a city that's on the coast, it is close to water. That's what that means. When you have a city that's close to water, you deal with the effects of that water during storms. Okay, so this is Puerto Rico after Maria. And you can see like feet of water moving through this particular city. Right? So cities that are on the coast are particularly vulnerable to the effects of climate change, storm surge, storm frequency, storm intensity, and storm duration. Okay? All of these things are ecological, they're social, they're structural. What I mean by structural is the built environment, right? And financial. Who is paying for it? How are you going to pay for it? Who needs things that they cannot afford? Okay? All of these things are effects of climate change on cities. So I want to take just a very brief minute and talk a little bit about wildfire. Wildfire in the United States, and it's not just the United States. That's another thing that I want to make very, very clear about wildfires. They are occurring globally. Okay, if you remember back to February of 2020, you'll remember that Australia was on fire. Right? There were fires raging across Australia. Some of those fires are still occurring. We have fires down in the Amazon. We have fires in Europe. We have fires in parts of Asia. We have fires in the African continent. Fires are worldwide. Fires are also natural. Okay? Fires have been controlled by humans for a very long time, and therefore we have not always understood how best to deal with fire or how to prepare for it. But I do want to say a couple of words about wildfire and climate change because it is so important to cities and human developments. Okay? Climate change has caused wildfire season to be longer. Okay, so we used to in the West, so now I'm just talking in the Western United States. I do not have the stats for this for other parts of the world. Okay? But in the Western part of the United States, we have increased our fire season from a 5-month season to a 7-month season just since the 1970s. Okay, so just in the time that I have been on this planet, we have added 2 months of fire to that part of the world. Okay, and when you think about, okay, now let's think about why that's important. Why is 2 more months of fire season a big deal? Well, you have to have firefighters. You have to have resources to fight that fire. You need water, you need PPE, you need transportation, helicopters, all sorts of things, right, to fight that fire longer. That takes money. That takes human power, right? Somebody to actually do the job. It takes resources to fuel all that, right? So to fuel the trucks, to fuel the helicopters, to fuel transportation. So just that aspect alone causes us to really consider that extra 2 months as being pretty significant, right? It's really significant. So we went from having about 140 wildfires per year back in the 80s to about 250 in the early 2000s. That has since increased since then, although I could not find the statistics to compare that in a meaningful way for you. But we are continuing to tick up, as we would say. Wildfires are more frequent, and an increase of about 100 annually every decade. That's a lot. That is a lot of fire. Why? Why is this happening? Because our risk is increasing. So because we didn't understand fire for so long, we have quite a buildup of fuel out in the western part of the United States. And when I'm talking about fuel, I'm talking about natural fuel, right? Not fossil fuels. I'm talking about sticks and leaves and dead trees. We add fuel as well when we have droughts. Okay? When it gets dry and the trees die, we're adding fuel in that way. When we have insect infestations, when insects kill the trees, that adds fuel to the fire. Okay? Winds have changed. Winds have become more intense. They swirl differently. And the weather patterns that we have out on the West Coast are much different than they were before. Those winds are also drying out the landscape, right? Drying out the trees quicker, drying out the soil faster. When you have an increase in fuel, you have an increase in the duration of the fire. sometimes in the intensity or the heat of the fire. And it takes many, many more resources to put that fire out. Now I want you to think about what's happening in urban areas. Okay, so wildfires, we talk about that in ecology, right? We talk about why wildfires are important in forests and how it helps with succession, et cetera. But what's happening in urban areas that causes these fires to be so intense? Okay. And this is just, so while you're thinking about that, I also want you to think about, this is a good graph out of a paper. I can post this paper for you if you'd like to read it. So these are the millions of acres burned through 2015. And these are the, it's kind of a comparison of what we might have without climate change, right? So fire happens, it happens. It's part of the natural ecosystem, like I said. They start from, typically we think of a wildfire as starting from lightning, but also in this particular case, we see this sort of uptick, but it's also from humans, right? That gender reveal party that they had out west started one of these major fires that's currently raging. People have died because of that. We also have cigarettes being tossed out of windows. We have PG&E, which is the electrical company out there, not keeping good, sound care of their lines that run through. And so those spark and those start fires. So fires happen, right? When you add climate change on top of that, drier temperatures, more intense wind, longer fire seasons, more intense fire seasons, then our fire regime is doubling and increasing rapidly over time. Okay? So it's not just, I don't want you to think that wildfires are all caused by climate change. They're not. Part of it is this sort of human moving into spaces that are urban and creating our own problems, right? But a lot of it is from climate change, and it's the intense multiplier, right? The risk multiplier of fire in these areas that's causing problems. So over the last 2 years, really, there's been no shortage of press on the California wildfires, and these are just some kind of screenshots of newspaper articles from all over California through the last couple of years. Losses and reached $2.5 billion, right? Who's paying for that, right? What kind of taxes are being paid? What kind of insurance is being paid? Does the government help pay this? Those are questions that all of these things are asking. Climate change has doubled the riskiest fire days in California. It was interesting because I did this screenshot when I was teaching environmental science in the spring quarter. And I took this just because we were getting close to fire season in California. And then lo and behold, throughout the whole rest of the summer now, we've been fighting fire out there. So one of the things that I want you to think about here, back to global fragmentation, right? And putting human developments and human buildings in spaces that used to be natural. So this is the California chaparral. And chaparral is an ecosystem type, and it is made up of sort of scrubby plants, not trees, right? Most of them are just little scrubby shrubs things. And it's pretty bare, okay? It's pretty bare. Some of these plants, if you've ever heard of creosote bush, and if you know that word creosote, you know that that is a fire accelerant. Okay? So creosote bush actually produces within its plant cells flame accelerants. And the reason that is because this particular environment has evolved with natural fires. So this plant produces this chemical so that it burns itself very quickly. If the plant burns quickly, then the roots are actually protected. Okay, and when the fire is over, rain comes back, the plant sprouts back up from the roots. Okay? So this particular area is what we would call fire adapted. And that's important to know because in California, we continue to build dwellings, houses, schools, shopping malls, all sorts of things in the beautiful California chaparral, an ecosystem that has evolved with fire to burn faster. Okay? So these are some questions we have to ask ourselves. What are we going to do about this? Right? How will people continue to live in these areas? And who is going to be able to leave? All right, and that's what I want to leave you with today. I'm sort of a sad and depressing note to end up on, but it's important to think about these things. So this is an article that I just pulled from yesterday's CNN report, right? It says wildfire weary Californians are, quote, tired of this being normal, and they consider uprooting their lives. And I want you to think about what it would take to move your entire family out of a space and what you would have to do in order to accomplish that. Okay, so you'd have to find a new house. You would have to find a new job. You would have to find maybe new daycare, new medical help if you have some sort of condition that requires consistent medical care. Maybe your family's here. Maybe your family in California helps take care of your child as you're going to school or as you're going to work. What would it mean to literally move out of a space that you consider your community, right? I'm not talking just about the emotional part of it. I'm also talking about the socioeconomic part of it. And do you think everybody can leave? Right? And that's something that we have to ask ourselves with climate change, is the people who are being hit the hardest in cities by the effects of climate change simply do not have the socioeconomics to move across the country and start over again. Okay? All right, I will leave you there. I hope you have a good afternoon, and I'm looking forward to talking with some of you today, Monday, about the book that we're reading. All right, I'll see you guys later. Bye-bye.